So, ladies and gentlemen,
And boys and girls.
welcome back, ladies and gentlemen. We're looking at last night's homework problem 22. We were talking about standard deviation and mean deviation here. So let's see. Looking at this, it says, during a recent season, 7,684 teams played 19 NCAA women's sports. The breakdown of these teams is given below. Blah. And then it says, what is the median number of blah, right? So all sorts of stuff. Actually, you know what might be interesting? No, I won't show this on the calculator yet. That'd be too easy. So I'm going to open up Excel, though, and I'm assuming eventually we're going to calculate some mean, median, mode, standard deviation stuff.
Friend.
Oh, whoa, thank you. Oh, thank you. You saved me, friend.
You're welcome.
So let's see, data. Let's see, we've got 966, 838. If you're interested, fast forward the video now so you can until you see this list is complete.
It'd be around 1 minute and 34 seconds.
282. Oh, I dyslexified that, I think. Nope, I didn't. 22. Hopefully they don't ask something specific about, like, women's swimming or something like. I just said swimming. That's weird. Swimming. 40, 691, 770, 26, 432, 859, 528, 644, 923, and 23 itself. So here's our list. So the first question they asked was, what is the median number of the women's teams playing a sport? So what I would need to do is sort this. Are you following along, friend?
Of course, friend.
So I data sort. There are 19 terms. So what term would be the median one?
The
Number 9. Number 10.
Number 10, I believe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the median one. It looks like it would have, 9 on both sides. So yeah, 280 dose would be the answer to that, which is what they had. And I'll just write my own answer again, verifying that that's what we had.
A class mark is also median. Wait,
A class mark is the average of the upper and lower limit of a class.
Well, wait, did you put that in order, though?
I did. Yep, I did. I sorted it. What was the question?
The mark is the middle of the limit, it's not the middle of the data within.
Right. The class mark may not even be in our list of data if we had a frequency distribution. So
Okay.
it's just the average value, or we would assume the average value in a frequency distribution. So let's see. What is the first quartile and the third quartile point? So let's see. If this is the middle. Now, of these 9 data points here, I want to find their median. So I think the 5th term would be the one. So I think 42 is that, and that is what I get. 42. And then of these 9 terms, their 5th one, 770, looks like the quartile 3, right? So there we go. We're on a roll. What is the interquartile range and the semi-interquartile range? So for C, the interquartile range is 770 minus 42, which is 728. And the interquartile range, nope, QR, that's the letter I was going for, would be 728 divided by 2.
Ever played that game?
Qbert?
Q-WAP.
Quap. Where you have to like balance the character, where there's like legs and momentum and blah blah blah. No, I haven't, but I've heard about it. I read about it once, actually.
Horrible game.
Let's see, D. Are there any outliers? How would I know? I would do 1.5 times the interquartile range, right? That was just the rule. So 1.5 times that is going to be something. I'm telling you.
I'm guessing it's gonna be through.
Well, you guys all did this problem already, so.
Yeah, but I was wrong.
Oh.
I'm saying no.
1092.
I'm saying
And
no.
how would I know whether or not there's any issues with this?
If
Well,
it's over the
I would do
last amount.
Q1 plus 1092. And if it's less than, oh, sorry, nope, I lied.
Q3 plus.
Q1 minus 1092 and Q3 plus 1092. All right. So let's see, I think I've got those written up here. Well, actually, there they are right there as well. So let's see, 42 minus 1092. Settle down there, friend. Negative 1050. So there's not going to be that, because you can't have that number of women's sports teams. Right? You can't have a negative number.
So the interquartile range is QR, and the
The semi-interquartile range is QR, where you take the interquartile and divide by 2. And then let's see, Q3 was 770 plus 1092
That's not it.
is 1868. 1862, sorry. So was there any data that was greater than 1862? No, there wasn't. So as a result, I would say no outliers. Okay? Outliers require a lot of calculation, unfortunately. It's kind of a weird, quirky one. Let's see, E, make a box and whisker plot of the numbers of teams. That sounds awesome, friend. So let's see. So what do I go up to? What's my highest number? 966. So I guess I could go from like 0 to 1,000, maybe. Right? And then like here's 500. And then let's see, 1,
2, 3,
4,
4,
1, 2, 3, 4. I divvied that up pretty good. I'm proud of myself. I can't
Give yourself a pat.
try
on
to
the back.
admit. Yeah, actually, right there. There we go. I don't know if the mic picks that up, but I hope it does. So let's see. What's my lowest point? I guess I'll alt-tab with this. My lowest point was 22, so here's the end point of one of my whiskers. 966 was my highest point, so there's another end point of one of my whiskers. My median was 282, so 282, there's my median, somewhere around there. Blah, blah. And then what was it, 770 and 42? So 770 and 42. And I draw my box. And the whiskers. And as you can see, that a lot of women's sports teams exist between the 22 and the 40, what was it, 6, 44? 42. So yeah, 25% of the data exists right here. So that's a very densely populated cluster, right? So you can see a lot of numbers exist between 22 and 42 right there. And then the most broadly dispersed group is quartile 2 to quartile 3. It seems like there's a wide range of possibilities there. So there's my box and whisker.
What's the middle of the middle box? The middle line box?
This is quartile 2, which is also known as the median, and then quartile 3, quartile 1. Right. And quartiles cut things into quarters. What is the mean of the number of women's teams playing a sport? I think my Excel spreadsheet calculated that, 404.42. Cha-ching. Find the mean deviation of the data. So to find the mean deviation, I take each data point, subtract the mean, absolute value, right? Add them up, and then divide by how many... Yes, okay. I was like, why is 19? But 19 is not the number of women's sports teams. It's the number of sports being played, I guess, would be how I would categorize it by this. So the mean deviation was 316, right? So 316.97 or so. Yep. and then find the variance of the data. Oh, I didn't talk about variance.
Yeah, see, that's why I screwed up,
Definitely.
Can't even do this one.
Let's see. It says the standard deviation is most important and widely used measure of variability. Another statistic used to describe the spread of the data about the mean is variance. Variance is denoted as sigma squared, the mean of the squares of the deviations from x. All right. So basically, the square of your standard deviation. So variance. Let's see. Let me reveal all of these. Right, you following along, friend? Okay, so variance would be what I had before I squared it. So actually, I could even insert a column here.
Do this on quiz.
No. So variance would be
Your name's screwed me all up by these.
this divided by this. So basically, slow down. Variance is just before I square root to find standard deviation, is all variance is. All right, so
What do those dollar symbols do again?
it locks it so that way even this cell is referring to that rather than having it accidentally have shifted down for each, and then it would mess it up. So in this case, there's my variance. And that's why they asked us about variance before standard deviation. And then it says, what's the standard deviation? About 344.55. So yeah, standard deviation larger than mean deviation. And then they ask about what about the variability of the data. So in regards to discussing this, I would say that the data is very densely clustered in the between the minimum point and your first quartile. And then it's much more broadly distributed after that, something like that, right? And so the variability was measured by the variance, the standard deviation, the mean deviation, and our box and whisker plot were all different ways we could kind of analyze how our data was distributed, right? So there we go. All right. So I think we're good with this. There's a problem all